All right, this is section 2.3. In this section, we're going to be talking about composition of functions. In the previous section, we added, subtracted, multiplied, divided functions. Those are some types of operations that we can do with functions. In this section, we are going to do another operation with functions called composition. Okay, um, so there's this business of composition of functions. This little picture sort of illustrates what's going on. So let's see. This little picture here, what's this represents here, let me begin with this little picture, is, see, like this is the input right here, input. And my input is going to go first into the function g, and then function g spits something else out. And that is the input for the new function f, which then spits something else out. So this function right here is written in this form, f of g of x. Yeah, so this right here, this little picture is illustrating f of g of x, which can also be written as f of g of x. Yeah, and so the thing to notice here is that, see, my input is x. That's this little ball right here. That's my input. That input first goes into the right function, into g. And then once g is done with that, then whatever came out of that goes into f. So you kind of want to read these things. So you have your input. Your input first goes into the rightmost function, g, and then it goes into the next one. And we could have even more. So I mean, I could even have a situation where I have something like this. H of f of g of x. And what this would mean is that my function x first has to go through g, and then the output of that has to go through f, and then the output of that then at the end has to go through h. So you could have a composition of more than two functions. You could have three functions, four functions. And I guess this would be written as h of f of g of x. Okay, so think of putting in one function into the other. And we're going to have to think about the domains of these things here, but we'll talk about the domain in a second here. Let's just kind of begin by trying to put the functions together. So again, kind of similar to the previous section, you're going to start off with two functions, f and g, and from those two functions you can form new ones. And the way you read this, for instance, up here, the way you would read this is f of g of x. F of g of x. This one you would read as g of f of x. And here we have a little bit of information about the domains. So x is in the domain of g, and its output is g of x is in the domain of f. We're going to have to think about that in a second, but for now, let's just get into some examples here and see if we can get these ideas. Okay, so we were given these two functions, 2x minus 5, and that's f of x, and my other function g of x is x squared minus 3x plus 8. And I'm being asked to compute six little things here. F of g of x, g of f of x, f of g of 7, g of f of 1, g of 1, f of x. I'm going to help you with part A, and then I'll give you a chance to try the other ones on your own. Okay, so let's do part A. So f of g of x, that means the following. It means f of g of x. Yeah? And think about what this means. So I am plugging the function g into the function f. Yeah? So anywhere, so let me look at my function f. F of x is this 2x minus 5. Anywhere where I have x's, so this x right here, is going to have to change to g of x. So I'm going to write it down like this. 2 g of x minus 5. So think about what I did there. So I was looking at my function f, which is over here, and I replaced all of the x's in my function f with the function g of x. That's what f of g of x means. Replace my new input for my function is g of x. So I replace that x right there with g of x. And notice that I put parentheses around that. Why? Because g of x is made up of 3 terms. And so now I'm actually going to write out what the terms are. So this becomes 2 times x squared minus 3x plus 8 minus 5. Okay, the next thing I'm going to do is I'm going to distribute this 2. So this 2 has to multiply all of these 3 terms. And then I'm going to collect like terms. So this becomes 2x squared minus 6x plus 16 minus 5. And now collecting like terms. 2x squared minus 6x plus 11. And that's it. That is my new function. So out of these 2 functions, f and g, I've come up with a new one. This is called f of g of x. It's a new function. Okay, now it's your turn. So take a moment here, pause this video, take a few minutes, and try to compute the other 5 things that are being asked of us in this little exercise. Alright, so hopefully you have answers, and we're just gonna compare. So you pause the video, and now you have some answers for these other 5 parts, and let's see what we get. So let's see here. This guy becomes sorry, this is something else. So here we have g of f of x. Okay, so what that means is I'm looking at the function g. Anywhere where I have x's in my function g, now I have to replace my x's with well, f of x. So it's going to look something like this. F of x squared. Oops. Let me kind of give myself more room here. F of x squared minus 3 times f of x plus 8. So notice what I did. See this x right here? Well, I changed it to f of x. So now it's f of x squared minus 3 times f of x plus 8. That's what this means. I am plugging the function f into the function g. Okay, so now let me actually write out what f of x is. And by the way, you don't need this step. This step that I'm doing here, I'm just doing it right now so that you sort of see what's going on. Later on in the other examples, I might omit it. So now what I have is the following. I have x, so 2x minus 5 squared, because that's what f of x is, minus 3 times 2x minus 5 plus 8. Yeah? And now I gotta FOIL this. I gotta FOIL this 2x minus 5. And I trust that you know how to do this. I'm just gonna tell you what it is. It's going to be 4x squared minus 20x plus 25. That's what you get if you actually square this binomial, 2x minus 5. So 2x minus 5 squared, remember, I'll give you kind of a little thing. So you have to do 2x minus 5 times 2x minus 5, right? That's what we have to do in order to conclude that how I ended up with 4x squared minus 20x plus 25. All right, so be careful with that. Let's see, now I have to distribute this negative 3. Let me just erase this. All right, so minus 6x plus 15 plus 8. See, I squared this. That's how I ended up with these first 3 terms. Then I distributed negative 3. That's how I have these other 2 terms, and then plus 8. And now it's a matter of collecting like terms. X squareds need to be added with x squareds, x's with x's, and numbers with numbers. All right, so I think we can conclude finally that this becomes 4x squared minus 26x, because the negative 20x minus 6x, and then 25 plus 15, that's going to be 40. 40 plus 8 is 48. And I think that's the answer for that part. Okay, so hopefully so far so good. Let's move on to the next one. Now I have to do f of g of 7. And well, there are two ways to do this. There's the long way that would involve first figuring out what is f of g of x, whatever that is. You have to come up with a new function here and then plugging in a 7 into that. That's one way to do it. Another way to do it, I think the shorter way, would be to do this. This is just going to become f of g of 7. Yeah? And so then I gotta compute what is g of 7, first of all. So what is g of 7? That means I have to plug in 7 into g. So let's see, what do we get? So that's going to become f. What would that be? That would be 49 minus 21. So 49 minus 21, that's what? I don't know how to add or subtract. 49 minus 21, that's 28 plus 8. Plus 8, that should be 36. So all I did is a little bit of arithmetic here. What is g of 7? I had to compute that. So I had to plug in a 7 up here into my function g. So that's 49 because it's 7 squared. So 49 minus 21. We said that 49 minus 21 is 28. Plus 8, that's 36. And then I have to plug in 36 now into my function f. So 36 times 2 is going to be 72. And then 72 minus 5 is going to be 67. So hopefully you see what happened here. So I put the 7 has to first go into g. 7 first has to go into g. G transforms it into 36. And then 36 has to go into f. And well, f then makes 36 become 67. Yeah? Alright, let's see. Let's think about the next one. So here what we have to say is g of f of 1. Okay? So first of all, I gotta compute f of 1. I gotta plug in 1 into f. Well, that's going to be 2 minus 5. That's negative 3. That means g of negative 3. So I hope that you see where I got this negative 3 from. This negative 3 comes from the fact that I plugged in 1 into f. That's what f of 1 is. F of 1 is negative 3. Okay, and now I gotta plug in negative 3 into g. So that's going to become 9, because negative 3 squared, just be careful with your signs there, it's a negative times a negative, so it's going to become positive 9, and then minus 3 times negative 3, well, that's another positive 9, so 9 plus 9, that's 18, 18 plus 8, 18 plus 8 is 26. Okay, so hopefully so far so good. You plugged in, so here in this little composition you had to plug in 1 into f first, which gives us negative 3, and then we have to plug in negative 3 into g. That's 9 plus 9 plus 8, so that's 26. Alright, let's move on to the next one. We gotta do g of 1. And that's okay. We can compose a function with itself. So this just means g of 1. Okay. So the first thing I gotta do is I gotta plug in 1 into g right here. What is g of 1? Because I need to know that. What is g of 1 right here inside this parenthesis? What's g of 1? So that's going to be 1 squared. So 1 minus 3, that's negative 2. 1 minus 3, that's negative 2. Negative 2 plus 8 is 6. So this becomes g of 6. I hope that you agree what I did there. So g of 1, that's the first thing I have to figure out. And g of 1, well, that's 1 minus 3, so we said negative 2. Negative 2 plus 8, that's 6. Now I have to compute g of 6. What is g of 6? Well, that would be 36. So 36 minus 18. So 36 minus 3 times 6, which is 18. So 36 minus 18, which is 18, plus 8. So that should become 26. Yeah. So hopefully we're on the same page at this point. G of 1 became 6. And now G of 6 is, let me just make sure here that my arithmetic is good. 36 minus 18 plus 8. Yeah, that's 26. So that's okay. Good. Notice that in this 3 exercises here, we've been getting numeric answers. Our answers is just a value, 67, 26. In the other ones, we were getting equations. We were getting a function. That's when the input is just x. Okay, so let's see this last one. So for the last one, what we gotta compute is f of x. Okay, so that means I gotta plug in f of x. I gotta plug in f of x anywhere into f of x. So anywhere where I have x's in f of x, I gotta replace those x's with f of x. Well, that becomes this, 2 f of x, what is it, minus 5. Okay. Well, let me just then replace, so that becomes 2x minus 5 minus 5. So then that becomes 4x minus 10 minus 5, or 4x minus 15. Okay, and so that's it for this first example. Hopefully we're on the same page here and we're getting the same answers. If not, then at least now you know how to go about this. All right, let's move on to the next part here. So now we're going to be doing something similar here. It's just now we're going to talk about the domain of a composition. So let me say something about that. So I'm going to say this. I'm going to say the domain of f of g of x is the set of numbers x, in the domain of g of x, in the domain of g, such that g of x is in the domain of f. That's quite a mouthful there, but let's see. So hopefully it's not, the mechanics of forming composition is not that bad. When I think the tricky part is determining the domain of a composition. I think that's where things get a little tricky. You gotta be careful. So let's try to sort of see the bigger picture here. So this composition of functions, f of g of x. X first has to go into g. And then g does something to that, the output goes through f, and then f does something to that, and then we're done. Well, if we wanted to determine the domain of this new function, f of g of x, we definitely need to make sure that we need to start off with the domain of g. Do you see why? Because x has to go through g first. Yeah? So anytime that you're trying to determine the domain of a composition, always first start with the domain of the rightmost function. Yeah? So the domain of f of g of x, in this particular case, first I have to just start off with the domain of g. And then I might have to restrict that domain a little bit further. But definitely first I have to start with the domain of G, because my x has to go through G first. If x cannot go through G, then it cannot go through the rest of the steps here. So anytime that you're trying to determine the domain of a composition, first consider the domain of the rightmost function. Yeah? Okay, let's see if we can apply this then. So we are given two functions, the square root of x and this other function x minus 3. We're supposed to do a couple of things. We're supposed to determine the compositions, so what we did in the previous example. So we're just gonna do the composition. And then we need to identify the domain, and then we need to make a little sketch of the composition. Yeah. So this is going to be, it's going to require a little bit of work, especially for the graphs. We're going to have to sketch a little graph of the composition, but I'll give you the opportunity to try it on your own. So pause this video, please. Take a few minutes and see if you can come up with at least the compositions and the domains. The graphs will sketch them and whatever, but at least come up with the composition and the domain of the composition. Okay, so hopefully you got a chance to do your work. And now, okay, so let's see. The first thing that I'm going to do here is I am going to begin by identifying the domains of the original functions. So the domain of f of x, is, I mean, remember, we do not want to have, we should not have negatives inside of my square root. So I don't want negative numbers. 0 is okay. 0 can be inside of the square root because the square root of 0 is just 0. So my domain here is 0 to infinity. That's the domain of f of x. The domain of g of x, that one's a little bit easier. That's negative infinity to positive infinity. I just want to put those, I want to write them down because we're going to need them to determine the domain of the compositions. All right, let me first compute the composition itself, and then I'll think about the domain in a second. So let me compute this guy. So this is going to become f of g of x. Okay, so then that means that anywhere where I have x's in my function f, I'm going to replace them with the function g. So this becomes the square root of g of x, which then becomes the square root of x minus 3. Okay, so that is it. That's the composition of the functions. So now here's the tricky part. I got to determine the domain of this new function. Yeah, so I gotta determine the domain of this new function. The way I always start to determine the domain of compositions is I think to myself, through which function does x have to go first? In this particular case, x has to go first through g. Yeah, so x has to go through g first. So I need to start first with the domain of g. And then I might need to make more restrictions to the domain of g. But I know that I need to start with the domain of g. And what's the domain of g? Oh, well, it was negative infinity to positive infinity. Okay, so I guess I'm going to begin. So the domain of the composition, I first have to start by thinking, okay, what's the domain of the outermost function, in this case g? Because remember, my x goes first to g and then goes into f. So right now, I gotta sort of think to myself, okay, the domain of g is negative infinity to positive infinity. But then I need to probably make more restrictions once, because there's other stuff involved. And now I guess I'm looking at the last, at the composition that we got, the square root of x minus 3. And turns out that this guy, so we do not want negatives inside of this, we do not want negatives inside here. So what we could do is just do this. X minus 3 is bigger than or equal to 0, and that would tell us that x is bigger than or equal to 3. And so then that corresponds to 3 to infinity. Yeah, it's all the things that are bigger than 3. But let's see, let's kind of recap what happened here. So we are trying to determine the domain of this new function. we're gonna start by assuming that the domain of this new function is just maybe the domain of g. Why? Because my x first has to go through g. Okay, well, the domain of g is negative infinity to positive infinity. But then since the output also has to go through f, then that means that there's going to be some other restrictions on the domain. And in order to make the other restrictions happen, sort of what you can do is just look at the result of the composition. And so now this is the domain that we're after. So the domain of this particular composition is 3 to infinity. Yeah? So that's kind of how we have to think about the domain of the composition. First, think about what's the domain of the outermost function, and then you might have to restrict it even further depending on your final result of your composition. Okay, let's try the second one. So in the second one, let me first do the composition itself. So that says g of f of x. Okay, so that's going to become the square root of x minus 3. Yeah, because over here in my function g of x, I gotta replace my x with f of x, which is the square root. So this is the result here. Okay, so let's think about the domain now. Let's think about the domain. So first of all, think about through which function does x go first? X goes first through f. Yeah, so x first goes through f. And so then I gotta start with thinking about the domain of f. And while the domain of f is from 0 to infinity, including 0. So 0 inclusive to infinity. And maybe I have to make it even smaller than this. Maybe I have to restrict this domain 0 to infinity a little bit further. But let's see. That would happen depending on what my final output told me over here of the composition. Think about what would be the domain of this thing here. Well, we still do not want zeros inside the square root. So we could do something like, well, just say x is bigger than or equal to 0. And well, that's just 0 to infinity as well. So this domain is just going to be 0 to infinity. This domain is the same domain as the domain of f. Yeah, but you always have to think about what is the domain of the function that x goes through first. Yeah. Okay, so that is it for the compositions and the domains. Let's try to get a little sketch of these graphs. And well, I mean, we can make the sketches by using a calculator or making a table of values. I'm just going to spare you a little bit of time here and kind of show you what the graphs look like. So right now, I'm going to sketch the graph of f of g of x. So let me sketch the graph of f of g of x. It looks something like this. This is f of g of x. It's this little curve that sort of curves upward and keeps on going up forever and ever and ever and ever, and it starts right here at x equals 3. And think about the domain. I mean, look at the domain of so the domain was from 3 to infinity. Well, that makes sense. Look at the graph over here. The domain is from 3 to infinity, including 3. That's why it's a solid dot there. Now let's sketch a graph of this other thing, g of f of x. Okay, this is the square root of x minus 3, and the graph looks something like this. Something like that. This guy is g of f of x. And if you look at the domain is from 0 to infinity. And well, that is what we have. Okay, so be careful with identifying the domain of a composition. It's definitely tricky. You always start by kind of thinking about the domain of the outermost function. The outermost function. Yeah. Okay. Well, that's it for this section. I'll see you in the next one. Thank you.